All right, so today's video is about curved mirrors. Last time we talked a bit about plane mirrors, where we had to use the law of reflection. But with a plane mirror, it's possible to do that because the mirror is flat, so it's easy to measure angles. Today, we're going to deal with curved mirrors, like this. And so what happens is, it becomes a lot more difficult to actually measure your angles. Because if you've got, for example, a beam of light that goes in like this, the question then becomes, well, how do I measure my angle? Because this is a curved surface. All right? So we actually have to rely on some geometry. So here we go. By the end of the video, you need to make sure you understand 3 rules. And these 3 rules describe how light will interact with a curved mirror. And then you need to be able to use those 3 rules to find the image of an object in a curved mirror. Okay? So the first thing I want to do is talk about concave mirrors. Okay? Concave mirrors are also sometimes called converging mirrors. All right? And the reason they're called converging mirrors is this. If you've got a concave mirror and light is shining into it, gotta make the sound effect or it doesn't work. What actually happens is, because of the shape of the mirror, the light ends up getting what's called converged to a point. Okay, so this top beam, when it hits this surface of the mirror here, it gets reflected kind of downwards, this way. All right, and it turns out if this is a perfectly spherical mirror and these beams are all parallel and travel along what's called the primary axis, I'll talk about that in a second, all of these beams reflect back through a common point. All right, and that point right there is called the focal point. Okay, so the idea is a converging mirror, a concave mirror, will take parallel beams of light and cause them all to pass through the focal point. All right. Now, it's worth noting that despite my terrible drawing here, this curved mirror here is supposed to be part of a sphere, part of a circle. And if you imagine that entire circle going all the way around, that circle would have a center point. All right. And it turns out that the distance between the focal point and the mirror, which is called your focal length, turns out that it's half of the radius. Okay, so your focal length is half of your radius. Some of you right now are mad because I used f to represent both the focal point and the focal distance, which, for whatever reason, is usually how it's done. It won't be a point. There wouldn't be an instance where you get confused over the two. So if it's a point, it's your focal point. If it's a distance, it's your focal distance. Okay? So, it turns out that this property of concave mirrors, that it takes parallel beams of light and makes it cross through the focal point, allows us to draw ray diagrams without actually ever measuring angles. Okay, and there are actually 3 rules that we're going to use. Okay, so here are those 3 rules. All right, the first rule basically says this. So you're going to have a mirror with a focal point and a center. This line that runs through the focal point and through the center is called your primary axis. All right. Now, it turns out that because of some simple geometry, any beam of light that passes through the center and then hits the mirror will bounce right back the way it came from. So if you have a beam of light that goes through the center and hits the mirror, that beam of light is going to reflect right back the way that it came from. All right. That's going to be rule number 1 that we're going to use for our ray diagrams. If you've got that sheet out in front of you, this sheet that I passed out in class, that is what rule number 1 is. Okay? Now, so any beam of light that passes through the center, so, you know, maybe you've got a beam of light that goes like this and goes through the center and hits the mirror, that's going to come back the way that it came from. If you've got a beam of light that goes straight down the primary axis, it'll come straight back down the primary axis. If you've got a beam of light that, whatever, you get the picture. Okay? So, that's rule number 1. Okay, rule number 2 says this. You've got your primary axis and your mirror with your focal point and your center. It turns out any beam of light that goes through the focal point, turns out any beam of light that goes parallel to the primary axis, and you already knew this, will then bounce back through the focal point. or on a line through the focal point. Okay? So no matter what, any beam of light that is parallel to the primary axis will bounce back through the focal point. Any beam of light that is parallel to the primary axis will bounce back through the focal point. Okay? So that's rule number 2, again, on your sheet. Rule number 2. Okay? And then the third rule is basically the same as rule number 2, but in reverse. So here's my focal point, here's my center. The third rule says this: any beam of light that goes through the focal point, not through the center, through the focal point, will reflect back parallel to the primary axis. So instead of going this way and then bouncing back through the focal point, we're going the other way. We're going through the focal point and then bouncing back parallel. Okay, so any beam of light that goes through the focal point will bounce back parallel to the primary axis. That is the third rule. Okay, so we're going to use those 3 rules to make ray diagrams. So dig out that sheet. What I'm going to do is, as I go through these examples, we're going to do 3 different examples of ray diagrams, and for each one, I'm going to follow these 3 rules. Okay, so I'm going to literally have a copy of this sheet in my hand. Hear that? That's me holding this sheet in my hand, and I'm going to read off of it and do exactly what it says as we go through and make the ray diagrams. Okay, so here we go. This is number 1. If you've got your packet 9.5 concave mirrors, this is number 1. Okay, it's got a little star next to it. Okay, because those are the ones I'm doing in the notes. There's actually one other one that I'm doing. But anyway, so here we go. So what I want to do is, here's my object. It's this little dude standing here. Hello. All right, we want to figure out where his reflection is. Okay, so I'm going to start just by reading the sheet. Object and center. Okay, this is going to be the beam that goes through the center. So what I'm going to do is I'm going to take my ruler, oops, and I'm going to line it up with the top of the object. You'll notice that my ruler is just barely touching the top of the object, and I'm going to rotate it so that the mirror, or so that the ruler, this is much easier to do with a real ruler than a pretend ruler. So my ruler is just barely touching the top of the object, right there. It's passing through the center. Okay, so what I'm going to do is I'm going to draw a beam of light. Let's see, line up the ruler with the top of the object in the center. Check. Reading from the sheet. Then draw a beam from the top of the object to the mirror. So here's my beam that's going to go from the top of the object to the mirror. Top of the object to the mirror. Just like that. Okay. The reflected ray goes right back the way it came from. So the reflected ray is just going to go straight back this way. All right, and just like we did with plane mirrors, we're always going to have to extend our reflected beam. So I'm going to now use a dotted line and extend it back the way that it came from. Okay? So there we go. That is beam number 1. Okay? Beam number 2 says parallel and then focal point. So I'm going to line up the ruler at the top of the object so it's parallel to the primary axis. I'm going to line up the ruler so it's parallel to the primary axis. It goes through the top of the object like that. Line up the ruler with the top of the object so it's parallel to the primary axis. Check. Now draw a ray that goes from the top of the object to the mirror. I'm going to do this one in blue. Top of the object to the mirror, parallel to the primary axis. Okay, draw a ray that goes from the top of the object to the mirror. Let's think of the point where the ray hits the mirror as point 2A. So that's point 2A right there. There's not a technical name, that is just a name that I came up with to help you. All right, now part B says use the ruler to line up the focal point with point 2A. So we're going to use the ruler to line up the focal point with point 2A. Again, this would be easier with a real ruler. Okay, so I've lined up the ruler, lined up the focal point with point 2A. The reflected beam goes from point 2A back along the ruler. Don't forget that the ruler, or that the beam reflects to the object side of the mirror. Okay, so I'm going to take my beam and I'm going to go from point 2A back along the mirror through the focal point, like that. And then I'm going to make my dotted line to extend it back the way that it came from. Okay, so there we go. That is beam number 2. And at this point, you want to start thinking about where they cross. And I'm noticing that my reflected beams both cross right here.
So that is a good thing. So hopefully my third beam will do the same thing. I don't know if you've noticed by this point, but each of the rules has a part A and B. Part A is the incident beam, B is the reflected beam. Okay? And I almost wish I had written it that way. Maybe I will do that in the future. Okay, so our third beam goes through the focal point and then parallel. So it says use the ruler to line up the top of the object with the focal point. So use the ruler to line up the top of the object with the focal point. So remember, we're going to call that good enough. All right, so I've lined up the top of the object with the focal point. Now draw a beam from the top of the object to the mirror. We'll do this one in green. Top of the object, through the focal point to the mirror, like that. You guys should be more careful than I am. This really is difficult to do with the sort of virtual ruler that I've got here. Okay, draw a beam from the top of the object to the mirror. Let's think of the point where this ray hits the mirror as point 3A. The reflected beam goes away from point 3A parallel to the primary axis. So I'm turning my ruler so it's parallel to the primary axis, connecting it to point 3A as best I can. And then I'm using my ruler to draw the line away from point 3A, like that. Don't forget to make your dotted line going the other way. There is beam number 3. And we are happy because all 3 beams have crossed at this same point. Okay, so let's get this ruler out of the way. Okay, so all of my beams started at the top of the object's head. That means the image is formed at the top of the object's head. So what I'm going to end up with is well, let me pause for a second. Technically what I should do is I should repeat this process for every point on the man, but that's going to take forever. So this dot represents the top of his head. Right, and the other thing I know is because his feet are on this primary axis down here, his image's feet are going to be on the primary axis. So I'm going to end up with a little upside down dude. So let me kind of clear this up, and here we go. Here's his feet and his legs, here's his arms and his head, and he's got a little smiley face there that you can't see. Okay, so that is our image. Okay, now we would describe this image as inverted because it's upside down. If it had not been upside down, it is called, unfortunately, erect. That's right side up. Okay. So that is one of the questions on the sheet. And then the other question is real or virtual. All right. An image is real if it's formed by actual beams of light. So in this one it is, because see these lines crossing here are solid beams of light. That means that it's real. So a real image is formed by actual light. Now, if our image had been formed out here by the dotted lines crossing, then you would call it virtual. All right, and what's happening there is there isn't actually any light crossing the point where you're seeing the image. It's just sort of an illusion. Your eyes are tricked into thinking that the image is coming from this point. Okay. The image that you see in a plane mirror from the last video, those were dotted lines crossing, and so that was a virtual image. All right, but this image here in this drawing is, in fact, a real image. All right, so there we go. That is one of our 3 drawings. Here we go. Drawing number 2. Same exact process. I'm going to do this one a little bit quicker. I'm not going to use the ruler for the whole thing. Because it's basically the same thing. Actually, for some of it I am. All right, so here we go. Going back to the rules. Number 1, line up the ruler with the top of the object in the center. Top of the object. Then draw a beam from the top of the object to the mirror. So we'll do this one in red again. Top of the object to the mirror. Oh no, pretend that was solid. Here we go. Top of the object to the mirror. The reflected beam goes right back the way it came from. So the reflected beam actually does go through the center. All right, and then don't forget your extension. All right, there we go. So that is beam number 1. Beam number 2, I'm going to skip the ruler for this one. It says line up the ruler with the top of the object so it's parallel to the primary axis, and draw a ray that goes from the top of the object to the mirror. So you're basically going to end up with, I'm going to draw this one in blue, you're going to end up with a beam that goes from the top of his head to the mirror. So that line that I just drew is parallel to the primary axis. If I had used my ruler, which I guess I probably should have just done in the first place, I would have lined up the ruler like that. Cool? All right, so there we go. Think of the point where it hits as point 2A. There's point 2A. Now, use the ruler to line up point 2A with the focal point, and the beam goes from point 2A back along the ruler. Don't forget to extend it. So something like this. Okay, so they all cross right here, so we're looking to be in good shape. Let's draw beam number 3. Beam number 3, use the ruler to line up the focal point with the top of the object. Now draw a beam from the top of the object to the mirror. Green, top of the object to the mirror. Think of the point where it hits as point 3A. The reflected beam goes away from point 3A, parallel to the primary axis. Oh no, I didn't do a great job here. Yeah, this is the problem with the virtual ruler. But so then what should happen is my reflected beam should go about like that. My extension should go about like that. And you can see I didn't quite get it, but if you do it with a real ruler, it should be a little bit easier, and they all cross right there. So again, that point represents the top of my dude's head. His feet need to be on the line. So here we go, giant image. So if you've ever been to the makeup counter at a random department store and looked at your pores all giant and scary, this is how that happens. It is formed by a converging mirror where your object is inside the focal length. Okay. So this image here is going to be erect because it is in fact right side up, and it's virtual because there's no real light behind the mirror over here. Okay, those are dotted lines. Okay. The last one I want to do is number 7. Number 7 is different from the ones that we've done because now our mirror is, instead of being concave, it is now convex. A convex mirror, is often called, instead of converging, it's called diverging. And the reason for that is your mirror is shaped like this. You've got a primary axis. Your beams of light go into the mirror, and instead of going back towards the focal point, they actually go away from a focal point. A beam going straight down the middle will go straight back. Okay, but it turns out if you, as we often do, extend the reflections, the extensions cross through a focal point. So your focal point would be here, and then as before, your center is twice as far away. Okay, so we end up with the same 3 rules, but often your beams of light don't go through the focal point or the center because the light doesn't go through the mirror. So here's the 3 rules again. You're going to have primary axis, curved mirror, focal point, center. So the idea is, if you've got a beam of light that goes through the center, well, it can't go through the center because your beams of light are going to start over here. So what you want to do is you want to imagine a beam of light that's pointed at the center, and if the mirror wasn't there, it would hit it. That beam of light is going to reflect right back the way it came from, and it's your extension that passes through that point. Okay, so here's another beam of light pointed at the center. It's not going to get there because the mirror gets in the way. It bounces back. Your extension passes through the center. Here's a beam of light going straight down. It bounces straight back. The extension goes through the center. So that's rule number 1. Rule number 2 says if you've got a beam of light that's parallel to the primary axis, it reflects not through the center, but directly away from the center. No, that's totally wrong. I apologize. It reflects not through the focal point, but away from the focal point. So your beam goes in, and instead of coming this way through the focal point, you can't see what I'm pointing at, it doesn't do this, it does this. Okay, so it's, again, the extension that passes through the focal point. Okay, so this beam of light's going to go, it's going to hit the mirror. The reflection doesn't go through the focal point, it goes away from the focal point. Okay, so again, the dotted lines represent the extensions of dotted lines. No, the dotted lines represent the extensions of the reflected beam. Sorry, this video is long, I apologize. So this is rule number 2. Rule number 3, focal point, center. Rule number 3 says if you aim a beam of light at the focal point, so this beam of light is aimed at the focal point, it's not going to get there because the mirror is in the way. That beam reflects away from, or reflects parallel to the primary axis. Okay? Here's another beam which is aimed at the focal point. It doesn't get there because the mirror is in the way, so it reflects parallel to the primary axis. Okay? So that one actually doesn't have anything passing through the focal point because the mirror got in the way and the reflected beam goes parallel. So there you go. All right, so last one, here we go. Let's draw this. Back to the sheet with the rules. Rule number 1, line up the ruler with the top of the object and the center. Top of the object and the center. Top of the object and the center. Oh, man. All right, well, that's going to have to do. Again, you guys can be more careful because you don't have pixels to deal with. All right, so here we go. Line up the ruler at the top of the object in the center. Draw a beam from the top of the object to the mirror. Top of the object to the mirror. Notice it doesn't actually hit the center. The reflected beam goes right back the way it came from. Remember to extend this beam beyond the mirror. There we go. There's beam number 1. Beam number 2, line up the ruler with the top of the object so it's parallel to the primary axis. Just like that. Line up the ruler with the top of the object so it's parallel to the primary axis. Now draw a ray that goes from the top of the object to the mirror. Blue. Here we go. Top of the object to the mirror. Think of the point where it hits the mirror as point 2A. 2A. Use the ruler to line up the focal point with point 2A. Focal point, point 2A. Oh, look at that. That was way too easy. All right. The reflected beam goes away from point, let's see. The reflected beam goes from point 2A back along the ruler. Don't forget, the beam reflects to the object side. Remember to extend it on the other side of the mirror. So I am right now noticing that, oh, my beam's crossed right here. All right, that's my reflected beams crossing. So hopefully the third one will follow suit. Beam number 3, focal point and parallel. Use the ruler to line up the top of the object with the focal point. Let's see, draw a beam from the top of the object to the mirror. Top of the object to the mirror. The reflected beam goes away from point 3A, so remember this was our point 3A, and it's going to go parallel to the primary axis. So I'm going to not use the ruler to save time. There we go. There's our beam 3. Don't forget to extend it. Dot, 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 dot. And notice they'll cross right here. So there's our image. Hello. Don't forget his feet are always on the line. This dude is, in fact, right side up and virtual. Cool? Cool. So that's how you do the ray diagrams.